Hello. In this knowledge clip, we discuss an important component of the consumer choice problem, namely the budget constraint. The budget constraint means that the consumer has only a limited amount of money available to spend on different goods. This is going to set therefore a limitation, or in other words, constraint on the choice. This is where scarcity appears in our model, and this is necessary so that we have an economic model at hand. So, as we discussed, economics is about choices under constraints. In this case, for the consumer choice problem, the constraint is simply the fact that there is a limited amount of nominal income, or I refer to this as money, even though somewhat incorrectly in the previous slide, which can be spent on a certain combination of goods. This constraint is called the budget constraint in economics. The budget constraint can be written up mathematically like this, where the nominal income is denoted by M and the price of a unit of X and Y is denoted by Px and Py respectively, while X and Y denote the amount of X or Y consumed. In more general speaking, of course, it is not necessary that the agent spends all of their income. So, in the basic case, the budget constraint can be written as an inequality, namely that M is either equal to or exceeds the total spending on these two goods. For simplicity, however, I'm going to assume that the consumer spends all of their income. In this case, this becomes an equality and actually makes our life a little bit easier. Let us see an example. We have a student who has a limitation of 15 euro to be spent daily on snacks and drinks at the university. The student has a choice between sandwiches, denoted by X, or soda, denoted by Y. One sandwich costs 3 euro and one can of soda costs 1.5 euro. Using this information, we can formulate the budget constraint as 15 equals 3 times X plus 1.5 Y. That is, in the left-hand side, we have the maximum amount which can be spent, and at the right-hand side, we have the value of a certain chosen consumer basket. Graphically, we can just simply draw a line representing all those combinations of X and Y for which only 15 euro needs to be paid. Exactly 15 euro to be more precise. So either someone buys 4 sandwiches and 2 sodas, or one may actually buy 8 sodas and only 1 sandwich. And both these choices are along the same budget constraint line, so they should both cost 15 euro exactly.
Let us continue with the budget constraint line we discussed in the previous slide. We know that by definition, any bundles, that is, any combinations of the two goods, which lie on the budget constraint line would cost 15 euros. Of course, the consumer may try to buy bundles which are not on the budget constraint line. If, for example, the consumer chooses 6 units of Y and 1 unit of X, then using the price information from the previous slide, we can immediately calculate that this bundle would cost 12 euros, which is less than the 15 euro available to the consumer. So this is an affordable choice. Of course, this means that part of the income will not be spent. And this may actually not be optimal, but we will return to that question in the next video clip. The consumer would really like to buy something like this. So 6 units of Y with 4 units of X would definitely be preferable. But if you calculate the cost of this, it would add up to 21 euros. So simply the 15 euro is not enough to buy this. We can generalize the concept as follows. All those bundles which lie to the right or above the budget constraint line are non-affordable. All those bundles which lie below or to the left of the budget constraint line will be affordable. Using this observation, we can already guess what happens if the nominal income of the consumer increases. No, those bundles which were non-affordable in the initial position will become affordable. So this can be represented by a rightward shift of the budget constraint line. If the income decreases, then we can model that by a leftward shift of the budget constraint line. When only the nominal income changes, the slope of the budget constraint line will not change. The reason is that the slope of the budget constraint line will be the ratio of the price of the two goods. So a change in nominal income will not affect the price ratio. As a result, the slope of the budget constraint line cannot change. Now we discuss how you can draw a budget constraint line. Because we have a line here, we only need 2 points to be able to draw it. That is, a line will be identified by 2 points. We can do this by using the intersects. For example, the intersect of the budget constraint line along the y-axis will be the case when all the income is spent on good Y and X, that is the consumption of good X, equals 0. In this case, because we have 15 euros altogether and 1 unit of Y costs 1.5 euros, we can calculate that we can buy at most 10 units of Y. Using the same reasoning, we can also look at the intercept along the axis X. No, we will set Y equal to 0. So all the 15 euro will be spent on good X, and each unit of the good costs 3 euros. This tells us that when all the income is spent on X, then you can buy only 5 units of X. These 2 points can be connected, and then we are going to have a line. Of course, you can just simply express the line's equation from the budget constraint itself by using algebra and getting Y to the left-hand side. You can already see that the slope of this line can be written as minus the ratio of the price of X and the price of Y. It is important, so please don't forget that when you calculate the slope of the budget constraint line, then you put the price of good X in the numerator and the good on the vertical axis, Y. So the price of Y will go to the denominator. You can see that in this case, and it is visible on the equation, the slope of the budget constraint line must be -2. So that means that if I want to buy 1 unit more of X, then I have to give up 2 units of Y. If I'm not willing to do that, then simply I would go for an unaffordable bundle. So I would just run out of money. What happens if we have an increase in the nominal income? So, for example, instead of having 15 euro available, we have 30 euro available. Then what we can do is, of course, to use the modified budget constraint to express the budget constraint line as an equation. And you can see that the slope of that equation, so the slope of the line, is going to remain -2. This is because there was no change in the two prices. but the intercept doubled. So because both of the intercepts will double, therefore we have the same slope, but we are going to have a rightward shift of the budget constraint line. Now we look at the case when the price ratio changes. Let's assume that the good X becomes more expensive. Previously it cost 3 euros per unit, but now it will cost 5 euros per unit. Now you can modify the budget constraint. So we have now 15 being equal to 5 times x plus 1.5 y. Using this and reorganizing this equation so that y is on the left-hand side, you can express the equation of the new budget constraint line. You can see that because the price of x was the only price that changed, the intercept along the vertical axis remains the same. But the new line will have a slope of minus 3.3. So the new line is going to be steeper than before, and it will tell us that under the new situation, if you want to buy 1 unit more of X, then you have to give up 3.3 units of Y. Let us look at the situation. Now we will look at another situation when the price of Y increases. Let's assume that the price of good Y increases from 1.5 euros per unit to 3 euros per unit. Now you can rewrite the budget constraint to 15 equals 3 times X plus 3 times Y, because the two goods have the same price now. Getting Y to the left-hand side of the equation will give us the equation for the new budget constraint line. So Y equals 5 minus X. So because the good Y became twice as expensive as before, the intercept along the axis Y will become 5. But because the price of the good X didn't change, the intercept along the horizontal axis, X, didn't change. Altogether, you can see that now we have a less steep, that is, a flatter budget constraint line as a result, and you can read it out from the equation 5 equals 5 minus x, that the slope of this equation will be minus 1. So if you want to consume 1 unit more of x, then you now have to give up only 1 euro of y. Of course, a price change is going to have an effect on the ability of the consumer to purchase goods. Even if only one of the goods become more expensive, then we can expect that altogether the consumer will be able to purchase less goods and services than before. That means that a change in the price ratio is going to change not the nominal income, but the real income. That is, the purchasing power of the nominal income is going to reduce. This will be very important when, in a later clip, we discuss the substitution and income effects. But how can you see whether the real income was affected by a price ratio change? First of all, originally, you could buy any bundles within this triangle. The area of this triangle could be used as some kind of analog of the purchasing power. In the new situation, the affordable goods are going to be much less numerous. And actually, you can see that the area of the new triangle is going to be less than the original. So there must be, therefore, a reduction in the purchasing power of the consumer, that is, the real income of the consumer. Of course, if one of the goods becomes cheaper, then it would be possible that the purchasing power of a given nominal income would increase. So changes in the price ratio may actually affect the available real income in two ways. They can increase it or reduce it.